Hi everyone, welcome back to my channel Vertex MrRoy. Exercise 12.2 is about the circular measures. But remember one thing in circular measures, we have all the angles in radian mode. So first of all, we should know what is the relation between the degree mode and the radian mode. So 180 degrees is always equals to pi radian. Actually, we are having about three angles, like units of angle, radian, degree, and gradient. So this is like what 180 degree equals to pi radian. When you want to write 1 degree is how many radians is pi upon 180 radians. And when you want to find is how many radians, like one radian is equals to, then it will become 180 degrees divided by pi. So this is the first relation you remember. Sometimes, for example, we need to convert, suppose 30 degrees, 30 degrees in radian mode. So what you will do, like you have to write pi upon 180 multiply by 30. So that will become 0 cancel out 3 times 6. So pi upon 60 is like 30 degree in radian mode. This is one example. Second example, when you want, like suppose sometime we have 3.6 radian and we need to convert into degree. So what we need, 1 radian equals to 180 divided by pi. So multiply by 3.6 and whatever the answer is coming, you can write that will convert into degree mode. If we take like whatever the value, just suppose 2 pi radian. So I will write 2 pi here. This pi and pi cancel out and just multiply is coming 360 degrees. This is the way this we should know how we can convert degree mode to radian mode in for angles. So degree and radian we have done. Now I'm moving to arc length. Before starting arc length, I would like to say something about the sector. The sector we have like a sector is a part of an angle to radius. Like this is radius, radii, this is r. This part is called the arc length. The arc length is normally we use a symbol S, arc length. So remember this arc length is S, radius is R. This is theta we use normally for this chapter. So now arc length which is equals to S, I'm writing S. So S is equals to R. Theta is the formula to find the arc length in radian mode. But when you use the formula to find the arc length in degree mode, remember we have done arc length is equals to what we do, theta upon 360 degree into 2 pi r. And if you want to convert this degree into radian mode, remember what is 360 degree equals to? 360 equals to 2 pi. When I write theta divided by this is 2 pi and 2 pi r is already there. So 2 pi cancel out. We have theta and r means r theta. So we have proved this the formula of the arc length in radian mode is r theta. This is like, uh, please remember in degree mode we have this formula and in radian mode we have this formula. Same thing when we convert the area of the sector in the radian mode, we can prove it. But I would like to write the formula. The area of the sector is half r squared theta, and there is one more possibility that's half r s because r theta is equal to s. So this is the two ways we can write the area of the sector when radius is given and the angle is given. Okay. What about the perimeter of this sector if you want to find? Because this is enough length of the arc length, the arc and the area of the sector and degree mode is enough. But I also would like to explain that how we can find the perimeter. So the perimeter means I am talking about all 1, 2, and 3, because perimeter means we are talking about the closed figure. So now perimeter of this sector is always equals to, now perimeter is coming like radius layer 2 times radius and the arc length. So this is very like here. And if you want to write the formula, but better to just remember like this. And arc length is here, and then we have. So this was the basic explanation. That's how we have to deal in this chapter 12.2. And I would like to do one of the question. Okay, 12.2 is here. Question number 1, we can see the length of the radius. We need to find the radius now. And if I consider only this part, so this is a sector, and this is also, there are two sectors. This is also a sector, this is also a sector. Now, length of the radius is about, now, this is a sector, and this is also a sector. Okay, let's see. We have 3.2 is the AB has the length of 3.2. So AB 3.2 means this is 3.2. The arc length is 3.2 centimeters from like AB. You can even write like this AB, and this you can write like this arc. And we have to find theta is 0.8 radians. So S equals to R theta, and R is equals to S upon theta. S is 3.2, and then you can simplify, decimal cancel out, and 4 centimeter is the radius. So we have done the first part to find the radius. Part B is, this was part A, the length of the arc BC. Now we have to find the length of the arc BC. So it means in second part we need to find CBR, like this is question mark. R is fixed 4 centimeter. And what is theta here? Theta, remember, we are talking about this part, this angle, this theta is required. So total sum of the angles in a straight line is 180 degree. So when a sum of the angle in a straight line is 180 degree, so 180 degree equals to how many radians? Pi radians. So what I will write, I will write theta is equals to pi minus 0.8, and you can get from the calculator. What's the value? The pi is minus 0.8, and the result is coming 2.34. Theta is coming 2.34. Now S equals to R theta, and we need to find S, and R is 4 and theta is 2.34. When we multiply with this 4, the answer is coming, S is equals to 9.366, means 367 centimeter, and that we have done question number 1. If I move to question number 2, we are having like so much possible, like the first part A, B, and C. So let's see. The radius is like 10 is fixed in this question. The radius is, I'm writing 10 centimeter, and theta will be changed for all the parts. Let's see. In A part is required. Find the value of the theta. Okay, theta is question mark. Theta is required. The R is fixed for all the values. And the AB length is for this part A, which is S, is equals to 14 centimeter. S equals to R theta, and R is 10. Theta is question mark, and arc length is 4. So theta is equals to 14 divided by 10 is coming 1.4 radian, and that we have done. Moving to part B. In part B, we have to find the length of the arc AB. Okay, so AB arc is required, which is S is required, and the theta for this part, particular part B, is 0.6 radians. And remember one thing, that the radius is fixed for the whole question. So S equals to r theta, and S equals to r is 10, and multiplied by 0.6 is coming 6 centimeter. And we have done this part. Moving to part C, R is fixed, and then we have to move area of the sector of AB. We have to find the area. Area of sector is required, and R is fixed, and theta for this, sorry, and the arc length AB, which is S, is equals to 5 centimeter. This is here, 5 centimeters. So now, what we have to do, area, we have two possibilities, half R square theta or half RS. So what is given? Area, S is given and R is given. So I have to use the first formula. R is like 10 squared, and theta is here arc is given, theta is not given, area of sector. Sorry, this is half RS. So we cannot use this formula. Sorry for this. Area is equals to half RS. This R is 10 and S is 5, and area is coming to 5, and 5 is 25 centimeter square, and we got the value of area. Part D, we are moving. In part D, you can see the arc length of AB is required when area is given. Okay, AB means the arc length S, like S is required, and area is given. Area is about 30 centimeters square, and we have to use like which formula, and remember the radius is 10, which is fixed. So RS, so I will use half RS formula. Area is 30 degree, like 30 centimeters square, sorry. R is 10 and S is required. Yes, and 2, this is 5, and 5 is AB arc is 6 centimeter, and we have done. So by this way, we have done the explanation of the circular measure and question number 1 and 2 of exercise 12.2. Next video, definitely I will continue the circular measure like with past paper questions. If you think this video is useful for you, please like my video, subscribe my channel, and share with your friends. Thank you so much, and have a nice day.